Hey everyone, welcome back to From Code to Cloud. I'm Maria, and today again I'm joined by our tech host Hristo.
Hey folks, great to be back. Today's episode is one I've been looking forward to, Kubernetes, the container orchestration.
This is episode 3 of our series, and we're diving into Kubernetes. Hristo actually wrote a great article about that titled Kubernetes the Basics. We'll link it below for you.
And today we'll break down the Kubernetes and give you a high-level peek under the hood. And since we can't cover everything in this short episode, please feel free to check out my Medium blog posts for more details.
Hristo, let's start from the top. How would you describe Kubernetes to someone who understands containers but hasn't used orchestration yet?
Imagine, Maria, that you're a developer and building an application with lots of microservices and containers. Docker works fine for your laptop for building and testing, but in production, things get tricky. So you need to scale automatically, right? Keeps everything healthy, handle the networking, and manage storage. Docker alone doesn't cover all of that. That's where orchestration comes in, and that's exactly what Kubernetes does. It takes care of managing your containers. Kubernetes takes your containers and adds a layer of automation on top, handling deployment, scaling, networking, and storage. So your apps run reliably, even at scale. Now, Kubernetes is the de facto platform for running microservices in production and works together with DevOps practices hand in hand.
So instead of manually watching over every container, Kubernetes ensures they are in the right place, scales them when needed, even restarts them if something fails.
That's right. So it schedules containers onto the right machines, monitor their health, manages networking and service discovery in a way that you can think of it as a cloud-native operating system designed specifically for containers.
Hristo, you have mentioned the term orchestrator a couple of times. What exactly does that mean in the context of Kubernetes?
Great question, Maria. So an orchestrator is just a system that manages your containers for you. Instead of doing everything manually, it automates the heavy lifting. It schedules containers onto the machines that have the capacity. It manages their life cycle, meaning that it's starting, stopping, or restarting them when needed. It's scale them up or down depending on the demand when it changes, and it monitor their health.
So Kubernetes isn't just a tool, but it sounds more like an entire platform with a lot of moving parts.
Exactly. And the way Kubernetes does this is by using layers of abstraction, or we call them levels. For example, infrastructure level and application level. At the infrastructure level, you have control plane and worker nodes. At the application level, you have things like pods, deployments, and namespaces, but we will check them later. And the networking and storage, we have services and persistent volumes, for example. One way to think about it, it's like the human body. So a container is a single cell. A pod is a tissue which contain a container or multiple containers. Then we have a deployment, which is like the organ that manages multiple tissues. We have worker node, which is the organ system. And in the end, the Kubernetes itself is the whole organism.
All right, let's dig into how Kubernetes is put together.
Okay, so at the highest level, Kubernetes is made of two main parts, the control plane and the worker nodes. And here we are talking for the infrastructure layer. You can think of the control plane as the brain of the system and the worker nodes as the muscles doing the heavy lifting, meaning they are running your containers. The control plane is constantly watching over the cluster to make sure it matches what you've asked for. And here are some key terms and ideas how it does it. So the desired state is when you declare the outcome you want. Like I want to have 3 replicas of my front end application. Then you have declarative model. So this is when you describe step by step, not to describe step by step what to do, but submit a configuration file that describe the end result. You have a manifests. Those configuration files are usually YAML or JSON files that you send to the API server, which is the front door of the Kubernetes. And we have a term that we call a reconciliation loop. So the control plane is always checking the difference between what's the currently running and what's declared and fixing any drifts.
So, if I understood correctly everything that you just said, instead of manually babysitting every container, you just describe what you want in a YAML file, and Kubernetes makes sure it stays that way.
Correct. So that's the heart of the Kubernetes. Declarative self-healing orchestration powered by manifests.
You have also mentioned the control plane and the worker nodes. Can we unpack each of them?
Yeah, sure thing. So Kubernetes follow the master worker model. So the control plane and the worker nodes work together. The control plane is the brain of the cluster, as we said, and it includes API server, and that's the front door, if you remember, that manages all the commands and manifests. etcd is a key value database that stores the cluster state. We have control manager that keeps the actual state aligned with the desired state, and we have the scheduler which decides which node will be run a new pod and the capacity management. Each worker node is like the muscle, once again, the analogy, that actually doing the work. So it has the kubelet that makes pods run as specified. We have container runtime, which is the engine that runs the containers. And we have kube proxy, that is the network manager, so to say.
From what I have gathered so far, on top of the infrastructure level, Kubernetes comes with another level called application. Can you tell us more about that?
Yeah, sure, Maria. So the second application level, as you call it, or also known as the workload abstraction, are those API resources that let you declare what should run and how it should behave. So without worrying about which machine or server is doing the work.
So they're like building blocks that developers interact with every day.
Right. The core workload resources you most oftenly see and use are pods, of course, which are the smallest unit that contain a container or more, replica sets that make sure the number of pods are running that you declared, deployments, which is building on top of the replication set or replica set, sorry, and adds additional features like updates, rollback, and rollouts, and services, which is managing the networking for the pods. We have also ConfigMaps and secrets that store configuration and sensitive data. And the last one most often used are the namespaces. This is an abstraction level an abstraction layer that organize resources within the cluster, often by team or project. So if you want a deeper dive into each Kubernetes resource, I've covered them all in detail on my Medium blog post.
So it's modular but structured. Once you get how these objects fit together, the model is actually quite powerful.
Exactly. And that's the best part. Kubernetes handles all this declaratively. And you describe what you want, and the system figures out how to get there and keep it that way.
So everyone, that's Kubernetes in a nutshell, an orchestrator that takes care of complexity, keeping your applications healthy, scalable, and reliable.
From its architecture to workload abstraction, everything in Kubernetes is declarative and automated. That's why it becomes the backbone of modern cloud native development.
Thank you for listening, everyone. If you want to dive deeper, check out Hristo's full blog post, Kubernetes The Basics, for all the details.
And stay tuned. Future episode will debug Kubernetes across different platforms and managed modules. Goodbye.
Bye, everyone.
Bye-bye.